IMéRA gave me the opportunity to start a new project that I wouldn't have started without, and I hope that I'll be able to collaborate with several of you, at least one, hopefully, but as much as possible. And since I'm the only one really in this kind of science, I'm going to try to make it, I mean, not really, I know several of you know about neuroscience, but some of you don't know anything. So I'll try to make it very simple and very accessible and have hopefully a lot of interaction and comment or questions. The concepts, the big concepts behind this, the global work that I'm doing since I started this project, the beginning of this project in UC Davis in California, but also how it's linked to this actual project, this current project right now. So enough little talks. First of all, we all have a brain. It's a very complex machine. It has a lot of neurons, mainly neurons, but also other cells that help the neuron in their function. And what's interesting about neurons is not so much the neurons individually, is the network they create with other neurons. So we have a lot of them, but we have, each of them have an average of 10,000 connections with other ones. So it creates an extremely complex network, and that's really a key in how the brain or any nervous tissue function. Now, when we look at this complex machine, we have to see the individual system. So it's like a small processor. All of you know about neurons. Neurons is pretty much a cell, like any other cell of the organism, but that has two extremely interesting features. The first one is it has those little things here, dendrites, that receive information from other neurons. And another system here that is resembling to those, but it goes in the other way. It sends informations. And the whole point of this little machine is to take informations, very complex information from, like we said, we saw previously about 10,000 other cells like this send information to this one at different timings. And this little thing has to process all of this spatially and temporally, make it in one simple message, and send it to other ones, other neurons. One interesting thing here to focus on for this talk, and especially this current project at the IMéRA, is the mechanism of communication that we found at the end of the axon or at the level of the dendrites from the other neurons. And it's a sort of little interface where two cells can communicate. Sometimes it's through electricity directly, but very often, the majority of the cases, it's a little protein, a neurotransmitter. It could also be something else, but the majority of them are proteins. And it's sent through, secreted in a very small space here, and you have what are called the receptors. So those are neurotransmitters. You have the receptors in the other side, and it creates a message. So inside a neuron, you'll hear me sometimes talking about cell signaling. Signaling inside a cell is a little cascade inside the cell of a lot of different sequences of proteins talking to each other, modifying each other. And so that's a communication inside the neuron, and outside the neuron, it's through synapses.